Welcome again to my YouTube channel, my beautiful people. What we're gonna do now is that we are gonna explore another method of one of those that we mentioned in one of those videos long ago to solve a quadratic equation. Remember, a quadratic equation is this equation of the form ax squared plus bx plus c, where a is different to 0 and that is equal to 0. So finding the solution to this equation is something that is extremely important in different scenarios, in different applied scenarios, like for example in physics or others. So the method that we're going to explore now is this last method that we have here, that is the quadratic function. The quadratic function is actually pretty related to the method of computing the square. So if you haven't seen the video of computing the square, I recommend you to go there in order to have all the information to understand the quadratic function. Why do we need that information? Because we are going to create the quadratic function. I'm not going to give you the formula of the quadratic function for you to start solving quadratic equations automatically, no, because you know what, we are better than that, because we always look for the understanding. And now we are going to understand what is the origin of this beautiful expression that is called the quadratic equation or the quadratic formula. So we are going to call this video finding the zeros of a quadratic equation with the quadratic formula. So what is the quadratic equation? The quadratic equation is that one that is written there. And what is the quadratic formula? Well, what I am gonna tell you is that I'm gonna let you know yet what is that quadratic formula, because the goal of this first part of the video is that we are going to deduce it and we are going to get our own quadratic formula. And for doing that, we are going to solve this equation, or better, we are going to clear the value of the x of this equation using the method that we discussed before, that was the completion of the square, or completing the square. Using this as our start point, we are going to start conducting a series of steps to find this formula that we're going to use in several different cases. So the first step that I'm going to follow is that I'm going to take this s that is adding here to in this side to subtract to the other side. And I will get an equation like this. Now that I have this, the next step that I'm going to follow is that I'm going to factor this expression. Factor why? Because I have I need this x squared to have a 1 as its coefficient. And in this moment, the coefficient is an a. What is a? I don't know, but the only thing that I know at this moment is that I really need this a out of this position. So I'm going to factor the a, taking it out, and I'm going to say that a times x squared plus bx over a, because I need to keep the balance or to keep the value of the function. So I'm going to draw bax, and all this stuff is equal to negative c. Now I'm gonna turn this element that is inside this parenthesis into a perfect square trinomial. How I'm gonna do that? I'm going to write again all this expression up to this position. So a times x squared plus b over a times x. And if you don't know this, I invite you to go to see a video of the computing the square. But at this point, you should know that this element that is going to complete this square is equal to 1/2 of this term that I have here of the term b. So it would be equal to b over 2a, and all this stuff squared. And as we just did this means that I need to keep the value of the function. So for doing that, I'm going to subtract from here the same value that I just created in this other position. And all this is equal to negative c. I can group this section of the polynomial that I have here. And as this is a perfect square trinomial, this means that I can factor it. And I will have that a times square root of the first element, that is x squared, the square root of x squared is equal to x. Plus, I keep the sign of the element b of the trinomial, so plus b, plus square root of the third element. Square root of the third element is b over 2a squared, and the square root of that expression would be b over 2a. And all this stuff squared. But what is the thing? I'm going to keep this expression that I have here, so I need an additional parenthesis, minus b over 2a squared. So, well, we could write this as b squared over 4a and 4, because 2a squared is equal to 4a squared, and all this stuff is equal to negative c. I'm going to use the distributive property of the multiplication to distribute this a among these two terms that I have in this binomial. So a times x plus b over 2a squared is equal to a times x plus b over 2a and all this stuff squared, minus, well, I have a times b squared over 4a squared. This stuff, simplifying this, I would have b squared over 4a, because this a cancels with this a squared, and all this expression is equal now to negative c. I will continue with this up here. So I have a times x plus b over 2a squared minus b squared over 4a. What happens? I can take this element that is subtracting here to add to this other side, and this is what I'm gonna do in this other step here. So I have this expression over here, and in this expression what I can do if I continue is that I can solve these two elements that I have here. I will do that in a different piece of paper. So I'm gonna solve this one here in this position. So this is the expression that I have here. What I'm gonna do is that I'm going to write a 1 here in this position, and then I'm going to continue solving this by multiplying this one times this one, which returns 4a, and 4a divided 4a equals 1, and 1 times b squared is equal to b squared, and 4a divided 1 is equal to 4a, and 4a times negative c is equal to negative 4ac. So we have this equation now. A times x plus b over 2a squared is equal to b squared minus 4ac divided 4a. What can I do with this? This a that is multiplying here can pass to a by to this position. So what I'm gonna write now is x plus b over 2a is equal to b squared minus 4ac over 4a squared. And now that I have that, I am missing the square here, and that square was important because that points to the next step that I have to complete, that is getting the square root of the two sides that I have here. So the next thing to do is calculating the square root of this stuff, because by calculating the square root of the two sides, I'm gonna get the following expression: x plus b over 2a, but the absolute value of this expression is equal to the square root of b squared minus 4ac over the square root of 4 is 2, and the square root of a squared is a. So I can write this. And why is this cool? Because now remember that the absolute value represents magnitude without the sign, alright? This is not considering the sign, so this means that the output of this expression could be positive or negative, and this is something that we are going to use in order to remove those modulo operators that I have here. I am going to write that x plus b over 2a is equal to positive or negative square root of b squared minus 4ac over 2a, and this may start looking familiar to you. This is what we got in the last step, and what we can do in order to clear this x is that we can move this one here to this position. So we will have that x is equal to negative b over 2a, positive negative plus minus b squared minus 4ac over 2a. And this, mes amis, my dear friends, is the quadratic function, because as we have the same denominator in these two elements that are being added here, then we can rewrite this as x equals 2 minus b más positive or negative square root of b squared minus 4ac over 2a. And this is the proof that this expression, this quadratic formula that I have here, that this one is the very famous quadratic formula is a solution that may help us in order to find the points where the function acquires a value equal to 0. That is what we are gonna do with an example in the next scene. Or no, that might be too long for a single video. We are going to create a second video for us to check an example of the application of this one. This video is just gonna be a proof of the quadratic formula, and then we're gonna create, or we're gonna see a second video where we see the implementation of this formula in an actual formula. So thank you. I hope that you enjoyed this proof as I did. I mean, it's great to understand the origin of the quadratic formula, and we see us in an upcoming video.